All right, guys, we are here for the Unit 9 review. Let's get going. Triangle RST is translated so that R is mapped to R prime. Name the rule of the translation and give the point. So you got to show how R gets to R prime, of course. And you go up and over. That's 2 up, 8 over. Okay. So first off, as a rule, going up and down affects your Y. Going up is adding. Going left and right affects your X. That's to the right is adding. So our rule is going to be X plus 8 Y plus 2. Okay. And then we need to apply that same movement to T, which you can do not nearly as straight. You can, do it on the graph, get there literally. You can figure out that T starts at 1/6 and then use the rule and add to it. So again, always several ways to do it. But T prime will wind up at 9, 8. Okay. Pretty simple stuff. Parallelogram WBMP is shown on the grid below. If WBMP is reflected across the line y equals x, what will be the coordinates of M? Let me see if I can do this. Y equals x is a line. It's perpendicular. Starts at... There we go. It's diagonal. From bottom left corner to the top right, goes through the origin, has a slope of 1 over 1. So when this reflects, basically what you're going to see is this flip over there and that flip over there. Okay? So M... hold on. Okay, sorry. So M... Let's try this. Prime is going to wind up where W was, which is at -6, -3. Another thing, if you look at the rules on your notes, y equals x, the rule changes from x comma y, transforms to y comma x. You'll notice M was at -3, -6 to begin with, and then you just flip the order, takes it there to -6, -3. Okay. Obviously, I can't show you the patty paper. You could have done this with patty paper also. If you're doing it with patty paper, trace the x and let me put that in red maybe. All right, trace the x and y axes. Good idea to trace the line too, and then the shape, and then you flip it over. With y equals x, you're going to flip diagonally from here, right? Like this bottom corner should flip up to meet that top corner, and the diagonal should stay on the patty paper lined up, right? I know it's hard to see, but hopefully we've done enough examples in class. Just wanted to add that in as well. Whoa. All right. Number 3, plot triangle RST and perform the following composites. R is at 1, 0. S is at 5, 0. T is at 3, 4. I'm going to try to draw a triangle. Probably won't be very nice. Not too bad. All right, so first x minus 4, y plus 2. So we'll take every point. Let's see. Let's do this. Move it back 4. 1, 2, 3, 4, up 2. Whoop, a little too messy there. There we go, and that'll be R prime, single prime, not double prime, sorry. Jumping the gun. S will move 1, 2, 3, 4, up 2. And T will move the same way. So 1, 2, 3, 4, 1, 2. You'll have a point just off the grid, not a big deal. T prime. We'll connect it the best we can. Yeah, not bad. All right, then reflects over the x-axis. So there's the x-axis. This is going to flip. The triangle will wind upside down. Will wind up upside down. And without patty paper, where you just flip it, what we're going to do here is, the simple way you probably learned it originally. This is the x-axis. I go 2 units up. I go 2 units down. Now we got our double prime. 2 units up, 2 units down. That's not R. Sneaky, that's S. Ooh, nice line. And then T is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 above. So it'll be 1, 2, 3, 4, 5, 6 above. 1, 2, 3, 4, 5, 6 below. About right there. And that's T double prime. Voila. Obviously, yours shouldn't have all those lines there, but it's cool. All right. Up to number 4. So we talked about these briefly at the beginning of the class. If I can fold the figure in half and the two halves coincide, match perfectly, and the figure has what is called line symmetry. So, you're trying to see, like, if I draw a straight line there, will it fold over? So the key here is this is not going to match anything over here. Those lines again. Is not going to match what's over there. If I do it across, same thing. This doesn't match anything over there. And a big messy thing on here to basically say no. Even though it looks like it's circular, because of the shapes inside, it will not. The face, you would think right down the middle, boom, got it right down the nose. Except when you fold it over, this eye, turn it red, will fold over and be over here. Will it let me? Let's see. It'll come up over there. And the eyes will not line up. And that will be the one thing that keeps it from being symmetrical. Almost perfect, except for the eyes. That sounds like some really deep song, right? Now the pen's doing it again. And then this one might look a little better on here than it does on your actual copy, but each of these limbs, snowflake lines, I don't know what they're called, they're identical. The key part is, so if you fold it, whether you do it here, it folds and this goes to that, that goes to that, that goes to that. Or if you fold it down the middle, right, this folds in half, that folds to that, that folds to that, this folds in half. So, long story short, 3. Rotational symmetry is, can you rotate it, and will it look the same as which it started before you get to a full 360-degree rotation. So kind of hard to show on here. I mean, I could rotate my iPad, but I don't think that's just going to let you look at it upside down. It'll just be me over here out in the world flipping it, and you're just looking at the paper while you hear me going, aha, look. All right, that was funny. But the key is these shapes here. So in all honesty, if you do 190-degree turn to the left, like our usual counterclockwise, you'll end up with this in the top left corner, this in the bottom, top right, both on the top. But notice how they're not in line like they are right now. When you do a 180, though, you're going to wind up with these two on the top lined up, these two on the bottom matched up. So, yeah. One works. The butterfly, nothing you can do to get it to look like this butterfly again before getting back to the full 360. So no on that. And then 3, yeah, it's kind of hard to tell, but basically these alternate, and then every other one is identical. Every one with the little black dot and the kind of gray shape alternates with the gray circle and the black dots, and so you can rotate it to match up. So that's a yes. 1 and 3. Toshiro drew figure A, then used figure A to form the following designs. Which transformation was used to create the designs? So figure A is a trapezoid. It doesn't matter that one of them doesn't say figure A. How do you get this shape to also make that shape and that shape? Well, translation is only moving left, right, up, down, but it would stay with the long line on the bottom, right? So you can't do that. You can't get this by just translating that, right? Reflections, this can become that, but you'd have to move it. You can just reflect it down, and technically it's asking what one transformation. So obviously it's a rotation. You take this shape, you rotate with this as your center. Like we look like we're in quadrant 1 because it looks like this is the origin. But if you use that as the center of rotation, right, then this is a 90-degree turn, 180, 270. But that's pretty obvious. Oh, right to the end. Rotations. All right, on to page 2. All right, let's do that. Okay, so this is going to be a hard one to do without patty paper, and that's the main thing I'm going to tell you. There's not a question exactly like this, but just to get the idea, if you reflect across y equals negative x, that's this line. It's going to wind up, let me see if I can do this. Something, I mean, obviously not that big, but, you know, this is hard to draw. And then you reflect it over the x-axis, and you're going to wind up, let's see, no, that's horrible. Kind of like that. Yeah, that's not good. Anyways, you're going to wind up with the shape, this shape down here, but this pointed down, basically ready to rotate into position. So let me see if I can get that one more time. Maybe something at least like that. So the idea on a problem like this is use the patty paper so that on the patty paper you have it set to right here, to where this is right now. And then you look, a clockwise rotation of 90 degrees. It rotates, and if you use the patty paper, it rotates right into that. So that's a check. Reflection over the line y equals negative x, and then a reflection across the y-axis. So negative x again is the line coming down here. It's going to flip it to kind of look like that. Oh, come on. That's horrible. Anyways, it's going to set it up so that then the second part reflects over y. Then it does flip into place. Okay, again, patty paper is going to make all this much easier to see. So let's just say that works. And then the same thing with 3. You take it from this position, over y equals x, flips it, because you'll be down here. Jiminy Christmas. You'll have this shape, it'll flip up here, and then reflect over the x-axis, we'll put it in there. So all 3 do work. Use patty paper. Using the coordinate planes, which transformations would move the figure A, B, C, D into quadrant 4? Translation. All right. What was that? Translate it down. Reflection. Why do you keep trying to move? Reflect. Let's forget the C, but that's all we're going to get. Are we going to get? That's over the x-axis. And then also, I guess I'll add it up here maybe. Rotation of 270 degrees. 1, 2, 3. 3 turns, 270. Okay. A land developer is dividing a tract of land into triangular-shaped parcels. The triangles are equilateral and have sides equal to 100 yards. He finds it is more efficient to make the parcels larger. He triples the length of each side. What will be the new perimeter? So you have a triangle, 100, 100, 100. Perimeter, obviously, 300. Then he makes it 3 times bigger. 300, 300, 300. Now, obviously, he did this. I mean, if you drew it like this, you can just add that together and get 900. But the other idea is if the scale factor is 3, scale factor for a side length will also apply to the perimeter because they're both one-dimensional. So you could have taken the original perimeter of 300, multiplied it by 3, and gotten 900. Either way, right, pretty simple. Remember, for area, you would have to square that so, well, the perimeter wouldn't be the same as the area. So if you found the area when the scale factor was 3, why do you not want to work? You would square the scale factor to 9 and do 9 times the area, but, you know, not here to see. The endpoints of PQ are -4, -4. Let me see if I can make this a little bit bigger. 1, 2, 3, 4, 1, 2, 3, 4. And the origin, 0, 0. No? Not going to let me use the origin? There you go. And endpoints, it should be P double prime, Q double prime at 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So somewhere way up here. And Q at 2, 3. So how do we get there? There's kind of 2 ways to get what would probably be the best way to do it first. And that is either a 180-degree rotation, or reflect over y equals negative x. Really? Apple products are the worst. I said it. So if you rotate 180, negative 4, 4 is going to wind up at positive 4, 4, because the rule there for a 180-degree rotation is negative x, negative y. It changes the signs. So with 4, 4 and 0, 0 being double numbers, it's going to wind up, Q stays where it's at, P goes to 4, 4. Rotation over y equals negative x is a negative y, negative x. So technically the numbers switch, but they're the same. So 4, 4. So either way, you get to P at positive 4, 4. And then you're basically just seeing how do you get, you know, these new points, because it's going to be 1, 2, 3, 4, 1, 2, 3, 4. For the moment, it's going to be like that. Nope. Yeah, right there. How do you get this to that? and that's just over 2 up 3. So the second part of that would be x plus 2, y plus 3. And the same thing, if you move where p winds up at 4 forward, it'll move to 6, 7. All right. Not everyone is going to have 2 possibilities at the front. It's just because of the numbers that were chosen that number 1 works like that. Plot triangle ABC with points at 2, 1. Let's see. 4, 0. And 3, 3. Close enough. Rotate the figure 180 degrees. Write the new points. So, again, a 180 degree rotation is going to keep the numbers the same, but flip the order. Change signs. So the 2 and the 1 stay in the order, but they change signs. To -2, -1 for A. B is going to be at, I just realized what I did there. This should be more like that. And that should be that, because that was the point. I just happened to write the B way far away from it. Is it going to erase anything? Apparently not. Doot, 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 doot. Does that help? Big old triangle. How about that? So that means B is going to be at negative. That's not going to help. -4, 0. And C is going to be at -3, 3. -3, -3. Horrible triangle, but you get the idea. And then reflected over y equals -x, which is that diagonal. And so, let's see, go blue. Like we said a minute ago, y equals -x, you're going to flip the order and change the numbers. So A will be at +1, 2. B will be at 0, 4. And C will be at 3, 3, which will take it back. So A is going to be at 1, 2. It's a little a, and big apostrophes. B is at 0, 4, double prime. C is at 3, 3, which is back here. And so it's connected at C and pretty close. All right. A rectangle has a perimeter of 28 and is dilated by a scale factor of 3. So really simple. The perimeter equals 28, like we said on the problem that's over here. Scale factor works the same for perimeter. So new perimeter is simply 28 times 3, which is 84. Okay. All right, one more page. Let's see if we can get this. Identify the dilation and find its scale factor. So by looking at the measurements, you can see that this goes here, originally like 6, and then on the bigger one, it goes out 16. Now, I know your first thought might be, well, 6 over 16. Except the dilation is an enlargement, right? And you know that, well, let me write it, kind of, one letter at a time, which is how you have to write. Close enough. Which would, as an enlargement, you have to make the shape bigger. 6 over 16 is a fraction that's going to make it smaller, right? So that would not make sense. So what actually you should do is simply flip the values. It's going to be a scale factor of 16 over 6, which reduces to 8 over 3. Not a good decimal with 3 in the denominator because obviously that's going to be 0.3 repeating, which, you know. So 8/3 is your scale factor. It's about 2.67, right, as a round off. Scale factor, center of dilation is 3, 1, 2, 3, 1, 2. So the center of dilation is right there. Right there. Jesus. And scale factor is 4. So basically you find the slope to each point and then multiply those numbers by 4. So that's down 1, which, is down 1 over 0. That's going to give you negative 4 over 0. So now down 1, 2, 3, 4. B is going to be down 1 over 1. Which will give you down 4 over 4. And C is going to be back 1. Which will give you 0 over negative 4. But of course, that's just back 4. And there you go. Bigger version of the triangle. And as we have talked about before, you should be able to draw straight lines from the center through the 3 points, which you can there. Okay? Almost done. Give me a All right, on this last one, you're supposed to describe the transformations from one to the other, right? So probably won't write these out, just listen to me as I talk. This one is a rotation, right? Because the only way you can get this to get like this is if you go, well, I should say, you could go the easiest way is clockwise, but we don't talk about that much. You could do a 270-degree rotation, 1, 2, 3, to wind up there. This to that is a translation over, up, x plus something, y plus something. And then this was we were supposed to change it. The black dot should be here. That should be clear. They don't have a white marker to override it. So the idea was this should have been a reflection. It just reflected over to the opposite side, right? So that the black dot was now on the left. And that was pretty straightforward. All right, hope that helped. Be ready for your test tomorrow. Bye. Oh, I did forget shout-outs, didn't I? Man, I got to go back and look who did shout-outs. If you got a shout-outs, shout out to Enter Name Here. All right, and don't forget shout-outs to Enter Name Here. Really thankful for that comment. And one last shout-out to Enter Name Here. Those are some really, really great comments, and I appreciate it. Keep it up.